Hi there, and welcome to this Project Data Science course, this mini course on the classic Iris dataset. My name is Steven. I'm the founder of Project Data Science, and I care deeply about teaching you how to do different aspects of data science. It's such a big, exciting field, and that's why I really love spending time helping people understand this a little better and be able to use it a little bit more. So this mini course here that you have signed up for is a little bit different than pretty much any other course out there. And that's because we're going to be going through an entire small data science project inside of a single Jupyter notebook. And you're going to be doing everything kind of beginning to end here. So you're going to learn how to do all of it, but it's going to be in a more compact form. And rather than spending a lot of time to make this project something that you might be, ready to deploy out into the world with a lot of different Python scripts and functions and whatever, we're going to take the approach of just sticking everything inside of a single notebook. And, so this might not be considered best practice if you're trying to actually produce a data science model to get out there to the world, although people are starting to use Jupyter Notebooks a lot more for production ready data science. Um, but in a fairly quick, like a fairly short fashion, and without having to deal with a lot of different tools and technology, you're going to be able to walk through a data science project beginning to end and at least get to touch each different piece of it. So I am really excited you're here. Let's go ahead and get started. So I'll be walking you through the data set and providing more context on everything as we go. So don't worry if you haven't used Jupyter Notebooks too extensively or anything like that. We'll talk through things more as we go. So the first thing we're going to do here is I'm going to open up a terminal here, and so I'm using a Mac. So let's see, it's over here on my other screen. Let me drag this over here. So I'm using terminal. On a Linux, it might be, a command line or bash. I'm using the command shell zish here, ZSH, but it's basically the same as bash. On a Windows, you might use the command line or PowerShell or something like that. There are going to be differences for different operating systems. But this is where I'm going to start by creating a folder that we can work in and then launching Jupyter Notebooks. And then we're going to spend the rest of the time in Jupyter Notebooks. So really quick, you are going to need to have Python and Jupyter Notebooks installed already. So if you don't know how to do that, I go over that in a lot more detail in the full courses, like the churn course, all that stuff. So you can always look there if you want to walk through that step by step. Otherwise, just Google how to install Mini Conda is how I would go about it. So Mini Conda spelled like that on the screen there. So just search how to install that and do that, and then you come back to this video. So I'm going to go ahead and navigate to my documents folder here on my computer. So cd change directory. And then I'm just going to make a new directory for this project. And I'm just going to call it Iris Jupyter course. So why don't we just call it that? And I'll change into this Iris Jupyter course directory here. And this is where, so I'll show you really quick if I do an ls to list the contents of the directory. We just created it. There's nothing in here. So it shows up empty. Which is exactly what we would expect. So we're going to be using Jupyter Notebooks inside of this directory just as a place to keep our notebook. And then if you wanted to later, you could use something like Git, Git version control to track your code, push it up to GitHub, all that kind of stuff if you want. And if you don't know what any of that means, that's fine. I also go over that in more detail in the churn course and other courses. So, but for now, not here to tell you about what we're not going to do. I'm here to tell you about what we're going to do. So let's go into Jupyter Notebook. So I'm going to type Jupyter Notebook and then this ampersand symbol. And the ampersand runs it in the background so that we can still use this terminal later if we need to, so that it doesn't occupy the whole terminal. So let's go ahead and run this. And you should have a window pop open in your browser. It popped open on my other screen here, so I had to drag it back over. So we run this, and back in our terminal, you'll see, okay, I have another Jupyter Notebook running somewhere else. So 8888 is already in use. So it's just running this on another port. Should pop it open automatically. And now we're in Jupyter Notebooks. So what we could do is we could go ahead and create a new Python 3 notebook. And actually, before we do that, one best practice when starting a new project is to create a new virtual environment to wrap everything up in, so that you keep all of your Python package installations kind of separate from everything else. So I'm going to come back over here. Let's look at my jobs. Let's stop this Jupyter Notebook. And let's take one step back. And you'll see here, just because of the terminal that I'm using, you'll see that I'm using my base Conda virtual environment. And I'm going to create a new virtual environment. And so Conda create in, let's call it Iris course. And basically what this is going to do is create a new Python installation and a place for us to install all of the packages that we want to install to use during this project. And then if we need to install something special that maybe doesn't work well with all the rest of the things that maybe our other projects are using, we have a nice small kind of wrapped up place where it's like, okay, our Python lives in there, our pandas install lives in there, matplotlib, all those kind of Python libraries that you use for data science stuff. So I'm going to install Jupyter in there because Jupyter is, in this case, a Python package that, or this is a tool that we're going to use to run Jupyter Notebooks, and we need to install it into our virtual environment. I'm going to install pandas, which helps us work with data. Let's install scikit-learn, which is our machine learning and modeling package. We can go ahead and install matplotlib, which is one of our plotting libraries, and Seaborn, which is another plotting library, which just gives us some nice styles and some nice functionality and stuff like that. And then I could go ahead and type NumPy here as well, which is used to work with data in Python, but that's actually also installed with pandas already, so we don't actually need to type that. I'll go ahead and type it anyways. So I hit enter here, and this is going to install a new Conda virtual environment for us to use, keep everything nice and wrapped up and separate, which is definitely a best practice. Even though a lot of people might not do it, this is going to be kind of industry best practice here. So let's go ahead and proceed. And this is installing not only all the things that we asked it to install, but also all of the dependencies that need to be installed for all of our packages to work as well. So it's going to take just a minute here to finish installing everything and giving us our nice virtual environment. All right, so our virtual environment is done installing, and you can see that it gives you very helpfully this information down here. To activate the environment, you just use conda activate and then the name of the environment that we specified. And then to deactivate it, we would just do conda deactivate, which we can do at the end of this whole process. So let's go ahead and activate it. And now I'm going to use one of my favorite command line commands, the which command. So we're going to ask which Python are we currently using? And if everything worked out correctly, this will be pointing to our new folder, which has our new virtual environment in it. So which Python, and this is now pointing to Anaconda 3 ins for virtual environment. Iris course, which is great because this is where we just installed our virtual environment, and then bin Python. So this is looking good. And same thing will happen if I type which Jupyter. So now this is going to point to our virtual environment folder here as well. And this is perfect because then if we needed to, we could totally delete that environment, start over, everything would be fine. We wouldn't have blown up our computer or anything like that. So now let's go back into Jupyter, Jupyter Notebook, and here we go. So I'm going to create a new Python 3 notebook that we can get started in. And why don't I go ahead and call this the Classic Iris Dataset. We'll just call it that. And so now that we are in the notebook, maybe one of the first things that I'll do is I'll go ahead and I'm going to use this exclamation point command here to run a command line command in this notebook, and I'll ask it which Python again, just to make sure that we are in fact in the correct virtual environment. Now, the next cell that I'm going to use here, and by the way, I'm walking you through, basically exactly how I would create a notebook here and the steps that I would take. And I think that this is one of the benefits of project data science courses is that I'm trying to fill in those gaps between theory and application, where you get to see exactly how I would approach a problem, the steps that I would go through, the ways that I would set things up. And in this case, it might be a little bit simpler than what I would usually do because we're doing kind of everything in a single Jupyter notebook here. But you're going to be able to see a lot of those gaps filled in of how to approach problems. So this cell is something that I really like to put at the top of every Jupyter notebook that I work in. These first two lines, auto reload, this is just a nice extension that if you're writing functions and classes outside of Jupyter notebooks, which we're not going to do in this case, but usually you would, and then you're importing them into Jupyter notebooks, that those functions and those classes will update in Jupyter notebooks when you update the code outside of Jupyter notebooks. And this is really important because otherwise you might be in a situation where you're updating your code, your scripts outside of Jupyter notebooks, and it's not changing inside of Jupyter notebooks, and you're like, what's going on? And it's using this auto reload extension is a great idea. And then this one just helps us with the matplotlib plotting here. So you can throw that up there as well. So next, I usually put my imports cell, and I like to divide this up into 3 different sections here just to help me organize my imports. So I'll do standard imports up here at the top. And I don't actually know if we're going to be using any standard Python imports this time, but these are things that come with Python. An example would be the OS or like the operating system library here. But I'll go ahead and leave this up here. I don't think we'll be using it. Third-party imports, these are going to be things that don't usually come with Python, but that you install separately. And examples here that we are going to use is we'll use pandas. We can go ahead and import that. We can go ahead and import NumPy. I'm not sure if we're going to use NumPy, but let's go ahead and import it. Import matplotlib. And the way that we typically do this is matplotlib.pyplot as PLT. And you'll notice that all of these have shortcuts that are just kind of the Python community has kind of decided that this is how we're going to name things. So pandas is usually referenced as PD, NumPy is in NP, PLT, all this kind of stuff. And we'll go ahead and import Seaborn as SNS. And then our local imports, this would be things like scripts that we write ourselves that we're importing. In this case, I don't think we're going to be doing that. We're going to keep everything in this notebook, but usually you would have some local imports here. So I'll go ahead and run this. And then there's one other thing that I do here, which is just kind of set So SNS seaborn.set, this is going to update our plotting styles within our notebook to use the Seaborn kind of plotting styles, which just, you can test it out and see what you prefer. I think the Seaborn plotting styles look pretty nice. So this is just kind of a configuration thing that I'll go ahead and run. And this is now looking good to go. So I will call this maybe notebook setup up here, just to keep it nice and organized. And every now and then I'm hitting Command S, by the way, to save the notebook. Make sure to save. Let's see, save and checkpoint might be what that is. Yeah, so I always just use Command S to save there. So now that we have our notebook set up, let's actually start talking about the data here. Let's talk about what we're going to be doing. So let's go to Iris dataset. Let's check this out. So I'm gonna click on the Iris dataset here from scikit-learn. All right, let's take a look at this. So this dataset consists of 3 different types of irises, and so an iris is a type of flower. And these different types of irises are the setosa, the versicolor, and the virginica. So it has their petal and sepal length and their petal and sepal width, and it has the species of flower, the type of flower that we were dealing with here. You can see some plots here that scikit-learn has. Let's go back. Let's look at the Wikipedia page really quickly. So this is a classic machine learning data set, a classic kind of statistical data set. This is very often one of the first classification data sets that people who are learning machine learning and learning data science will use to test out some of these concepts. And the reason is that it's fairly small. It's pretty nice. Like it has some pretty nice properties, and you can get some pretty good results pretty quickly. So that's why people will start with this a lot of the time, and that's why we're doing that right now. So, oh, and here are some irises. Yeah, they're pretty beautiful actually. And this data set was collected by biologist Ronald Fisher and used in the 1936 paper. All right. So the question becomes, how are we going to get this data set? And for this project, there's actually a really nice way to get this data. And let's create a new markdown cell here. So load data. By the way, I'm using the letter M to change to a markdown cell. And, a markdown cell is one where you can type and format things differently and such. And then I'll put some, just here's some like example. Here's some example Python code. So all right. So a markdown cell is just text. It's just text that you can format. And that's one of the beautiful things about Jupyter Notebooks is that you can alternate between code. So we have Python code running in these cells and text. So we can document what we're doing as we're doing it. So I'll go ahead and delete this cell because we don't need it, but I'm using M to change a cell to markdown, and you can use the letter Y. So you just hit the letter Y to change a cell back to code. So we're going to load the iris flower data set using, and in this case, we're going to use scikit-learn's, using scikit-learn's built-in data sets. So scikit-learn, which we'll use for modeling, has this data set already built into it, which makes it really nice and easy to go ahead and load. So we're going to say from sklearn import datasets. And by the way, I'm using tab complete here. So you hit the tab and it brings up all the different things that you can import. And then here we can say data equals data sets, which we just imported. And if you type the period here and then tab, then you can see what all we have access to actually under scikit-learn datasets. So there's a lot of data in here, actually. There's this thing called the 20 news groups data set. I believe that's a natural language processing text data. You've got California housing, which is a classic data set. You've got Boston and breast cancer and diabetes data sets, which are all classic. You've got digits, and then here's the one we're looking for, load iris. And now if you're wondering, okay, what does load iris do? Well, let's delete this really quick. Let's put a question mark here and do shift enter to run this, and the documentation is going to pop up. So this is the documentation for what the load iris function does. So datasets.load iris. So this loads and returns the iris dataset, which is a classification problem, and it has 3 different classes that we're going to be classifying. So it's not binary classification, which would just be 2 classes. We might call this, multi-class classification. So classes 3. So we have samples per class. We have 50 samples per class. So 150 samples total. And the features, it tells us here, are real and positive. So real meaning floats, meaning not integers. They have decimal places. And it returns data in the data type here is a bunch. So what is a bunch? Well, it's a dictionary-like object where the interesting attributes are data, target names, feature names, description. All right, so it's just going to return this data bunch thing. So let's go ahead and do this. So we'll say data equals this. We'll do shift enter to run that cell. And since it's a dictionary-like object, we can run .keys on it. So let's see here. All right, so data.keys. And so we see we have access to what it was just saying that we had access to: data, target names, etc. First, let's print the description. And this is a lot of kind of the same stuff that we were just looking at. It's also got some summary statistics, though. So this is a description of our data set here. So let's look at actually the data itself. So let's access the data key here of our data bunch. And you'll see here that we have 4 columns and we got a bunch of different rows here. And these are going to correspond to the 4, you see here, number of attributes, 4 numeric predictive attributes. So, and these are called our features in machine learning. That's kind of one of the main names that you're going to see is features for the X data here. So what are the names of these different features? And I'm gonna look at let's just look at the first maybe 5 rows here. So let's do data feature names. All right, so we've got sepal length. So that's this first column. Sepal width is the second column, petal length and petal width. So these are our 4 different features, which are different aspects of these flowers. And what we're going to try to do is we're going to try to predict the target, which is this array of numbers here. And let's look at target names. Okay, so you see here that our target just gives us a 0, a 1, or a 2. And this is indicating whether or not the flower that the measurement is from is a setosa, a versicolor, or a virginica. So you see that the first 50 data points here are from Setosa, the next 50 are from versicolor, the next 50 are from virginica, and we want to learn how to predict that species of flower based on these first 4 data points here. So that's kind of the problem that we're dealing with. That's the specification, and we can actually write that down really quick. So let's create a cell here, which is saying, what problem are we trying to solve? We are trying to use attributes of flowers to predict the species of the flower. Specifically, we are trying to use the sepal length and width and the petal length and width to predict if an iris flower is of type Setosa, versicolor, or virginica. This is a multi-class classification problem. All right, and I'll go ahead and save. And now what we can do is let's start looking at some of the data.